We got action. Oh, so tired. Right, now we have action. What?
I saw the word.
Right. Another boring lesson.
Yeah.
Another boring but easy lesson. Does anybody know this word?
Yeah.
Go on, Sean, tell us what it is.
I forget.
I know, you just don't want to say. Go on, explain it.
Really? Tell us forget.
No, please.
Okay, anyone else know? Oh, this standard deviation, and this would be an unstandard one? What are you talking about? You're crazy. It is when it is. Come on, give me a break. Does anyone actually know what it is?
Choose the.
Okay, go on, Sean.
Choose the date and use another date to minus this one.
Yeah?
Maybe.
Maybe. It is a difference, yeah, but how? Yeah, we don't know. I thought maybe somebody knew. No? Okay, so one problem with the average is that it only tells us, where the center of the data is. So consider this data: minus 100, 0, and 100. What's the average here? Yeah, which average? Very good. The mean average, 0. The median average is 0 as well. Yeah.
No, the mean is not 0. Median is 0.
Minus 100, 0, 100.
Yeah, median. Oh, I thought it was 100.
Okay. What's the average here?
0.
Now, what's the average here?
0.
But we can see the two data sets are quite different, although they both have an average of 0. This one is much more spread out. So if we were to imagine data on a number line, Monica, stop with your hands. So this is our data, and this is the average. The standard deviation is how spread out it is. Stop. This. Yeah, okay. So what exactly is the standard deviation? Well, firstly, let's say what it roughly is. Roughly, it's the average distance to the center, to the average. So for example, let's take some numbers here, like minus 100, 0, and 100. How far away is each of them from the center? Well,
100.
Minus 100, that's 100 away.
Yeah.
From the average of 0. And then the point here, 100, how far away is that?
100.
100. And this is also 100. And 0, how far away is that? 0. Now what's the average of those three numbers? 0, 100, and 0? 66. Yeah. So if you were to look at this data, the average distance to the center is 66.7. Because the average of 100, 0, and 100 is 66.7.
Why does 0 count?
But 0 is 0 away from the average, because the average is 0. And let's take another example, okay? So let's say we have 1, 2, 3, 4, and 5. What's the average here?
3.
3, isn't it? Okay, how far away is the number 1 from it?
2.
2 units away. And how far is 2? 1. And how far away is 3? 0. And then this one? 1. And then this one is 2. So if I add these up, 2, 1, 2, 1, 6 divided by 1, 2, 3, 4, 5 is 6 divided by 5 is 1.2. So if you look at this data, the average distance to the center is 1.2 units. That's how far away the points are from the average, on average. Do you understand? So the standard deviation is like telling us normally how far away the points are from the center. So when the data is very big, this number will be very big because the points can be very spread out. So we don't actually calculate the standard deviation like this. We have a different formula for calculating it. There's a couple of formulas. I'll give you the easiest one. Okay? And I'll use this one as an example. 1, 2, 3, 4, 5. So the formula for the standard deviation, and my pen stopped working.
What is the even?
Doesn't matter. Let me just turn my pad back on. It turned off because it's a jerk. Right, we back? Come on, don't be a jerk. There we go. Okay, so the formula is this. Standard deviation, which is this symbol, okay, equals, and let's say our data is x1, x2, x3, etc. to xn. The average is, the standard deviation is, blah, 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 blah. You square, well, there's a root. Now there's two formulas shown, they're both the same answer though. So the formula I would like you to use is this one, actually this one. Standard deviation squared is the sum of the data squared, each number squared, add up and divide by n, minus the sum of the data added up, divide by n, and squared. This is the formula that can give you the average, the standard deviation. Jerry, please, give your poor tired teacher a break. Got that?
Yes.
Let's have a look at an example. So, let's take the example of the numbers 1, 2, 3, 4, 5. Okay? So, what we do first is we add up all the squares. Yeah, 1 plus 4 plus 9 plus 16 plus 25. Yeah. over 5. Okay, and then minus just the regular mean average, 1 plus 2 plus 3 plus 4 plus 5 over 5 squared. So let's see what this is. That is 10, 14, 20, 30, 55 over 5. Is that 11? Minus 3? 9.
No.
Yeah. So, standard deviation is 1.41.
Yes.
Yeah. Now, what's interesting is, even though this formula looks quite strange, notice how this answer is quite similar to the answer I got here. I got an answer of 1.2. So this is roughly equal to the average difference between the mean and the data. Roughly. Now it's not exactly, it's not exact, but if you make the data bigger, more points, you maybe won't be surprised to know that this actually gets closer and closer. Now you might be thinking, well, why don't we just use the other formula where you get the difference and divide by the average? There are very complicated reasons why we don't do that. In fact, it is better to use this definition than what we think the definition should be, because this definition actually later turns out to be more useful. Which I know it seems a bit strange, but actually is more useful. So, 1.41. What that means is the numbers 1, 2, 3, 4, 5, they're roughly 1.41 away from 3 on average. Okay? You actually did something like this in physics. When you calculated the average and the uncertainty, what you were actually calculating was something like the average and the standard deviation. There's some things which are quite interesting about the standard deviation. If you calculate the mean average, and then you do a plus a standard deviation or a minus a standard deviation. So in my last example, that would have been 3 plus or minus 1.41. What does that equal? Let me see, that would be 1.59, 4.41. How many of my numbers, 1, 2, 3, 4, 5, are in this bracket? 2, 3, and 4. 3 of them are in this range, correct? 1, 2, 3, 4, 5. 2, 3, and 4 are in this. What's confusing you, Sean? Is number 2 in this range? Yeah. 3? Yeah. 4? Yeah. 5? No. Yeah. So, in other words, most of the data is within one standard deviation. Now, do you remember in physics we did the uncertainty? We said the uncertainty means the true value is mostly within that range, about 68% or 70% of the time. If I use 2 standard deviations, I would get 3 plus or minus 2.82. Now, what's the biggest number here? 5.82. And the smallest number? 0.18. Now, all of the data is inside of it. Okay. What about 3 standard deviations? Well, in that case, it's all of it as well. So what you see happening with the standard deviation is when you use one standard deviation, you get most. Maybe something like about 70%. When you 2 standard deviations, yeah, nearly, but still it's actually most. it's about 90, not quite that much, maybe about 96%. 3 standard deviations, that would be about 99%, maybe 0.9. 4 standard deviations would be like 99.99%, and then 5 and 6 standard deviations, that would be maybe 99.999%, and then this would be 99.123. It doesn't actually approach 100. You could still have data that has 1 point outside of your plus or minus 6 standard deviations. It's possible. I can give you an example. So here's an example. Do I still have this data here? No, I don't. Let's just make up some random numbers. 1, 5, 2, 4, 6, 8, 2, 1, 10. Okay. Minus 2. Right, so the mean and the standard deviation. Oh, what the heck is it? I think it's this. Okay. Now let me do lower and upper. So if I do this minus this and this plus this, are all my numbers in this range? No. Are most of them? Yeah. Okay, well, let's try if I do something like 6 standard deviations. 6, and here 6. Now, are all my numbers in it? Yeah. But what about if I do this now? Minus 20,000.
No. Yes.
No, it's not. Lower is 18,000 and upper is 36,000. The lower one is still too big. So you might say, okay, well, what about, okay, not 6 standard deviations, what about 60 standard deviations?
No.
No. What's the lower one? The lower one now is, what's it? Still too big. Okay, what about 600 standard deviations?
No.
Okay. What about 10,000
Nope.
standard deviations?
It's getting bigger.
Oh, because I typed it in backwards. Hold on. That minus 10 of these. Okay, that's better. So with 10 of them I've got it. Yeah. And that is that plus 10 of these. Okay, well if I just add an extra 0 here, lower is minus.
Yep.
Okay, don't worry, I can get it out. There we go.
Yep.
Still including it?
This is getting awkward.
I need more numbers now. Anyway, trust me, it's possible but gets harder. So you can't actually reach 100%. There's always a possibility that 1 point is not within the range specified. These are the common ones to use. So you would say the data is the average plus or minus a standard deviation. Or sometimes people use 2 standard deviations. Yeah. And that's really it. Okay, so can I see which questions I would like you to do? I just want you to do number 1. And that's it. Because that's all you need.